Okay, these are the remaining reactions. We will start with aldehydes. And for aldehydes, I have two types of reactions. The first one is reduction. And remember that reduction means adding hydrogen. What will happen here, okay, we have two versions of the same reaction. What will happen here is that this hydrogen that I can represent as two separate atoms will break the double bond here, and this double bond will become two different electrons. One electron will remain with the carbon. This is the carbon. And the other electron will remain with the oxygen. So one of the hydrogens will enter in the carbon, and the other hydrogen will attach to the oxygen. In this way, when I reduce an aldehyde, it will become a primary alcohol. This is the opposite reaction of alcohol's oxidation, partial oxidation. Okay? Is this clear?
Yes.
Okay. Then, when I oxidize an aldehyde, this oxidation is exactly the second phase or the second step of a primary alcohol oxidation. Let me write it completed here. Alcohol oxidation. If you remember, when I oxidize a primary alcohol, in the first step it becomes an aldehyde. If I continue with the oxidation reaction, it will become a carboxylic acid. This second step is what we have here. The aldehyde becoming an acid. We have already seen this reaction before with alcohols. It's just the second phase. For ketones, reduction is very similar to the one of aldehydes. Again, the double bond breaks. The double bond between oxygen and carbon breaks. One hydrogen goes to the oxygen. The other hydrogen goes to the carbon. And in this way, a ketone will become a secondary alcohol. This reaction is the opposite of oxidizing a secondary alcohol. Oxidation will go in this direction. Reduction is the opposite. When I oxidize a secondary alcohol, it becomes a ketone. When I reduce a ketone, it will become a secondary alcohol. And if you remember, when I oxidize a secondary alcohol, there's only one step. It becomes a ketone, and then nothing else happens. Ketones will not oxidize easily. It is possible to oxidize a ketone, but I will need a special procedure that we will not see here. For practical purposes here, ketones will not oxidize. Is this clear? Sure? Okay. For carboxylic acids, we have three different types of reaction. Esterification is the same esterification we saw with alcohols. And remember that it is an alcohol that combines with an acid to form an ester. It doesn't matter which compound you use first. The acid plus the alcohol plus the acid, it is exactly the same. And you just need to remember how to name esters. Remember here that the part of the molecule that came from the alcohol will become the eel. The part of the molecule that came from the acid will become the OH. No questions? You already know esterification. Yes. It's what is left after the reaction. Amidation means forming amides. And here we will have 3 different types of amides. For primary amides, if I want to produce a primary amide, I will need to combine a carboxylic acid with ammonia. Ammonia is NH3, and the result will be the primary amide and the water molecule that formed from the condensation reaction. In the 3 amidation reactions, a water molecule is released. The hydroxyl group from the acid goes out with one of the hydrogens from the amine or ammonia. They will form a water molecule, and the 2 remaining pieces will get together to form the amide. For secondary amides, again, I have the carboxylic acid, but in this case it will combine with a primary amine. How do I know this is a primary amine? Why primary? Why it is primary? Because the nitrogen is attached to only 1 carbon. Primary amines, nitrogen, only 1 carbon. And it has 2 remaining hydrogens. In the moment I combine this with the acid, it will become a secondary amide because now this nitrogen is attached to 2 carbons. It will become a secondary nitrogen. And we will have the water molecule that forms from the condensation reaction. Questions here? Yes?
Is it really necessary to put the chain in the end, or is it just...
The ethyl?
Yeah.
Of course, because if not, what will you do with it? If it is a primary amine, you cannot take away anything but hydrogens. If you delete the ethyl in this case, it will not be a secondary amide. And if you want a tertiary amide, again we start with the carboxylic acid, and here I will combine it with a secondary amine. A secondary amine means I have a nitrogen attached to 2 carbons. After the condensation reaction, it will become a tertiary nitrogen because it has 3 carbons. It has no hydrogens anymore. This is a tertiary amide and the corresponding water molecule. And finally, reduction of carboxylic acids is exactly the opposite reaction from primary alcohols oxidation. If I make this reaction this way, I will need here to add oxygen, and here oxygen. I start with the alcohol that becomes an aldehyde that becomes a carboxylic acid. Reduction is the opposite. I start with the carboxylic acid, I add hydrogen to get the aldehyde, and then I add more hydrogen to get the primary alcohol. When I stop in the aldehyde, it is partial reduction. When I go to the alcohol, it is total reduction. Of course, this includes the reduction of an aldehyde. That is only the second part. Okay? This reaction is exactly the same we have here. Okay? Questions? Sure. With this, we have checked this. Oh, let me make it red. Reduction, oxidation, reduction, oxidation, esterification, amidation, and reduction. So, we have finished with reactions.
So
Only with the reactions for this third partial exam.
catalytic reduction is the same as reduction.
Yes. It is named catalytic because it needs a catalyst. It is just from the program. We are not going to study the catalyst.